Hello everyone, welcome to Yourpedia Education. Today we are here some important questions that are related to BEL exam. Today we are going to discuss analog electronics and electromagnetic field theory. So as you know, the BEL exam on 20th of December. So this is the time, this is a crucial time for all of you to solve the questions. Try to do as much as you can do solve the questions, right? For that one, Yourpedia already launched the one book for that dedicatedly for BL ebook, right? In that book you can get around 2000 questions. This is the most important time for all of you. I'm again saying that thing. This is most important time for you. Just solve as much as questions you can solve before going to exam, right? And do the revisions. Here in BEL exam, short notes will also help because it is not a gate exam. This is a BEL exam in which they generally ask the short concepts and formulas, right? So basically, you have to make the short notes when you prepare and when you studied or when you are doing that thing, right? If you have short notes, just to revise them and try to solve as much as questions as possible, right? So let us start with analog electronics first. So first 50 questions from analog electronics that are equally important for both electronics and electrical, right? The second we discuss the electromagnetic field questions that are again equally important for both electrical and electronics, right? If you are going for BEL exam, these are the very good questions for you. Determine, the first question is what? Determine current I for the network shown below. We have to find the current, how much current I is flowing through this network. Okay. So for that one, the first thing what is come in your mind, that how much voltage at this terminal. Yeah, how much voltage at this terminal? That is 20 volt. Now I go for the other terminal at this side. That terminal has how much voltage? 4 volt. Whenever we see these things, what will come in our mind? This diode is forward bias and this one is reverse bias because its positive terminal is connected to lower voltage, negative terminal connected to high voltage, and this diode is forward bias, right? After getting these things, the first diode can be replaced by a 0.7 volt battery. So if I redraw this circuit, that can be redrawn as 0.7 volt, and then we will have here 20, this is 4, this is 0.7, and this is the resistance of 2.2 kilo ohm, right? So we have to calculate the I from this circuit. So if you want to calculate the I, how much is the voltage difference across this 2.2 kilo ohm? That will be, if I write the equation for I, that will be 20 minus 0.7 minus 4 divided by 2.2. Right. If you solve this, you will get the 6.95 answer. Right. So this is the basic question because he is giving the different values. See, 20 minus 4 is 16. 16 minus 4 is around uh, 16 minus 0.7 is going to be 15.3. You will get the idea that 2.2, right? If you divide the 5.3 with 2.2, then how much is that value? That value will be lying around 7, right? Like 7.5 or 7, but it will be around 7, not 7.5, because it is 2.2. So it means that value is 6.95. So you have to guess these things, right? No need to solve completely there. Next is using a DC and AC voltmeter to measure the output signal from a filtered circuit. Right, we have obtained the reading of 25 DC and 1.5 the RMS. Calculate the ripple filter output voltage. So first we calculate the ripple factor for that one. The ripple factor, right? The ripple factor is how much? VRMS divided by VDC into 100. So he directly not giving you the values, He directly in a different way he tell you that we are having DC and AC voltmeter. Generally DC voltmeter measure the DC value of that signal and AC voltmeter measure the RMS value. The readings are 1.5 and 25. So how much is this? 1.5 upon 25 into 100. That is going to be 6%. Answer is B for that one also. Next is, okay, which of the following is the main application of Zener diode? So basically the Zener diode is mostly used for what purpose? Zener diode mostly used for voltage regulation, right? The Zener diode is used for what? Voltage regulation. Correct. Most of the answer, most of the students giving the correct answer. That is Zener diode is used for voltage regulation. See, one more important thing about the Zener diode. Zener diode can also be used for a rectification purpose, but that is not the main use of Zener diode. Don't be confused with this thing. That if you are giving these options, you think that Zener diode can also be used as a rectifier because it is a normal diode, right? Zener diode, you can use that. See, some persons are asking that the Zener diode, Saurav Kumar, right? Saurav Kumar is asking that Zener diode is using in reverse breakdown, but you can use the Zener diode in forward bias also. As I already discussed this thing in class, that you can use the Zener diode in forward bias also, but problem is that in forward bias it will be work like a normal diode. Why we go for Zener diode? If it is similar to normal diode, then we will use the normal diode instead of Zener diode there, right? So it's not having any such application which is different from normal diode in forward bias. So that's why it is not practically used in forward bias. It is generally used in reverse breakdown region. In reverse breakdown region, it will be work as a voltage regulator. So main use of Zener diode is as a voltage regulator. Understood everyone? Yes. Okay. Ripple frequency in full wave rectifier. How much is the ripple frequency of a full wave rectifier? Try to solve it. Yes. Basically, whenever we are talking about ripple frequency means what? See, basically, if you draw the output of a full wave rectifier, the output of a full wave rectifier is like this. If you are giving a sinusoidal signal to this one, that sinusoidal signal is having like this wave. So basically what you are observing is the frequency, or you can say the time period of this input signal. This input sinusoidal signal is t, then the time period is become half, because it will repeat itself after t by 2. So it means its frequency is going to be double, right? The frequency is going to be double of the input frequency. Check. Anyone have any doubt? Yes, I think no. Right. Let's move to the next. The ripple factor in case of full wave rectifier. Ripple factor is different. Ripple frequency is different. Don't be confused. Right? Yeah. Whenever we are going for ripple factor, the ripple factor of a full wave rectifier generally defined as what? AC voltage divided by DC average. And this is the formula for that ripple factor. If you go for full wave rectifier, that is 48%. If you go for the half wave rectifier, you have to memorize these things, right? Because generally you are no need to calculate in the exam, you can memorize these things, right? So in full wave rectifier ripple factor is 0.48. Oh, sorry, yeah, and half wave is 1.21. So it is full wave rectifier, that is 0.48 answer. Let's discuss this. Yes. A full wave rectifier circuit in center tape transformer time. He is talking about center tape transformer type, right? if voltage between one end of secondary winding and the center tape is 300 peak, the peak inverse voltage will be, if you remember, in this center tape transformer type, that is have a problem. The main problem is that its peak inverse voltage, right? Peak inverse voltage means what? Whenever you are using the rectifier and inside the rectifier your diodes are reverse bias, so in the reverse bias, how much voltage will be across the diode, right? In reverse bias, how much voltage across the diode? See, generally what we are observing in reverse bias, if the higher voltage across the diode will be burned out. So we are trying to use that circuit which is having low peak inverse voltage, because every diode has its limit. Let us take, you are using a diode whose limit is that it can tolerate only 5 volt, and you apply a reverse voltage across that one 10 volt, then that diode will be damaged. So that's why we are using the circuit in which the peak inverse voltage is less. So that is the drawback of this full wave rectifier circuit with center tape transformer, that its peak inverse voltage is twice of the vm means applied peak voltage, right? So that answer is going to be 2 times 300, that means 600 volt is the peak inverse voltage, right? Okay, Harshit. Harshit is asking that what you want, Harshit. Said I repeat everything what I told you. See, basically what happened in. Okay, let me draw the circuit of this one. See, this is center tape transformer type. Here we are connect at the center of the transformer. We are connecting, and we are having a diode here. Right here, load circuit is here, and another diode is connected here in the center tape transformer type. So basically, when you do it is given to you the voltage between this terminal is 300 volt. Let us take in the positive half cycle. In the positive half cycle, the first diode is on and the second diode is off. This diode is off for us. This is off currently. So when it is off, so what is happening here in center tape transformer, if this is 300, this is also 300. So across this diode currently what you are observing, this 300 is coming out to with across this, and another 300 will coming out because this voltage is applied across the load, and load voltage will also be appear across this diode. So across this diode we are having two voltages right now. One is 300, another one second 300. So here we are getting how much voltage? 600 volt, right? Understood? So that's why if you are going with the what center tape transformer type, in that case the peak inverse voltage is going to be 2 vm. In bridge type rectifier it is vm. In half wave rectifier it is also vm. Next, as compared to full wave rectifier using two diode, the four wave bridge rectifier circuit has a dominant advantage. See, already I discussed this thing with you, right? That means it is the peak inverse voltage, lower peak inverse voltage requirement, right? That is the advantage. That's why we are moving with the four ways bridge rectifier. In bridge rectifier we are having the peak inverse voltage, right? Bridge rectifier we are having the peak inverse voltage that is equals to the vm. Okay, how much is the form factor of a half wave rectifier's sine wave is? Form factor, yes please. if you go for form factor, that will be RMS value upon average value, right? If you go for half wave rectifier case, in half wave rectifier, how much is the RMS value? The half wave rectifier RMS value is Vm by 2 and average value is Vm by pi. If you take the ratio of these two things, we are getting pi by 2 and pi by 2 is 1.57. So what will be the answer? The half wave rectifier form factor is going to be 1.57. Okay, let's not reveal the answer this time, right? Try to solve it. Anurag Reddy is giving C, C, B, C, 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 C. Don't write multiple times, right? Only write once the answer, right? Okay, most of the persons giving the answer, right? Bridge rectifier are preferred because they require small transformer, less peak inverse voltage. C, A and B. Yeah, what is the answer? C. C is the correct answer because if you are talking about the bridge rectifier, it is require only one transformer that is a small in size, but that is at the you can say the input side where we are getting the voltage that is 220 volt from the supply, because our complete circuit cannot work at 220 volts. So what we do, we step down that voltage by using a step down transformer there, right? That's why it is require only a single and very small transformer, that is a step down transformer. After that we are having a bridge rectifier, that circuit, right? And in bridge rectifier we are having most important advantage of that one, that is, the most important advantage of this bridge rectifier is what? Its peak inverse voltage is less as compared to center tap. The answer will be C here. Yes, question is this. Yes, try to solve it. This is not 1.3. Remember, this is 13 volt here. 13 volt. Check and solve. 13 volt. Yes, please. Yes, please. Okay, the answer is 6.9. 0.7 plus 6.3, 6.9. That's good. Because it is 13 volt. So what happen if it is 13 volt? 13 volt is going here. 13 volt is going here, right? Due to this 13 volt, this is 6.9. This is going to be forward bias because it is connected in this polarity, and this lower diode will be reverse bias. So if it is forward bias, that will be replaced by a battery of 0.7 volt like this, and this will be replaced by a battery of 6.3 volt. So 6.3 volt here, 0.7 volt here, that is going to be 6.9 volt at the output. So answer will be 6.9 volt. Yes. Yeah. Yes. Very good. The answer is D. See, always remember one thing. Always remember one thing. You are having a diode like this, and currently it is forward bias, right? It is forward bias. Let's take here is 100 milliampere current is flowing through this diode. Remember, 100 milliampere current is flowing through this diode in this direction. As you suddenly reverse bias this diode, the diode will not get suddenly means at the at that particular time it will not going to be reverse bias. It will take certain time, that is called as transient time of diode. At and during this transient time the current will flow on the same direction. It means if the 100 ampere current is flowing through that diode, it will continue until the transient time is not completed. As the transient time completed, the current becomes zero, right? So he's asking about the at the t equals to zero. T equals to zero, the same amount of current will flow through the diode. So answer will be 100 milliampere. These are the small concept, right? Remember that. Yes. Tell the answer of this one. The half wave rectifier, the load current flows for what part of the cycle? Half wave rectifier, the current will flow for what part of cycle? The current will flow the 180 degree, means if you check it here, the current will flow only for the half cycle. This is 180 degree, right? Complete cycle is 360 degree, the half cycle is 180 degree. Yes, this is. In a full wave rectifier, the current in each diode flow for whole cycle of the input signal, half cycle of the input signal? Tell me the answer. The B. See, basically he is talking about each diode, not the complete circuit. In each diode, the top or bottom, if you take the center tape transformer, the top diode, the current will flow for half cycle, and the bottom one is also flow for half cycle. So each diode, the current will flow half cycle, right? The top diode current will flow half cycle, bottom diode current will flow for half cycle. So what we can say, half cycle for the input for each diode. The question is not like he is asking about for both the diode the current will flow or from the load. If I talk about the load current will flow for both cycles, positive as well as the negative, in the same direction. That's why it will be doing the rectification. But if he is talking about the diode, the current will flow only for the half cycle. Understood? Right. Yes. To get a peak load voltage of 40-volt output of a bridge rectifier, what is the approximate RMS value of secondary voltage? This is the easy question. The RMS value is Vm by root 2. Very good. This is a bridge rectifier. C is the answer. 28.3. Correct. That is Vm by 2. The output RMS voltage is Vm by 2. From there, you can calculate the value of VRMS, that is Vm. Vm is 40 divided by root 2. So 40 divided by root 2. Root 2 is 1 point. How much is the value of root 2? When you divide this 40 by 1.414, it's around give you 28.3. Yes, please. The RMS value of load current in a half wave rectifier is RMS value in half wave rectifier, that is Im by 2. Good. Im by 2. Yes. The percentage regulation of a half wave rectifier. This is the formula for, if you are asking for percentage regulation means what? That is for all the circuit. If they are doing the regulation, that will be no load voltage or no load current minus load voltage divided by load voltage into 100. If you are from any background, you should know this formula, right? Very good. The equivalent DC output voltage of a half wave rectifier is the equivalent DC voltage of a full wave rectifier. He is asking about the DC voltage. DC voltage of a half wave rectifier related to full wave rectifier. What is the formula for half wave rectifier? That is Vm over pi, and full wave rectifier twice Vm over pi. So what will be the answer? That will be half. Oh, sorry, not 2. This is pi. Twice Vm over pi. Got it? Okay. Yes, try to do it. टेक्निकल से भाई 100 क्वेश्चन आएंगे. पेपर बीएल का इजी होता है, राइट? इट्स नॉट डिफिकल्ट. Madhu, she is saying that answer is D. Okay, anyone else? Okay, now I'm getting the answer, both mostly answering D. Yes, very good, correct. Answer is D. See, basically, if you are having a clamper circuit, clamper means what it will do? What is the function of a clamper? The clamper will clamp the waveform, will change the waveform, right? It will be shifting the waveform either above, either below. Yes, wave shifter. Good. So basically, when we are talking about RC time constant, so first thing inside that clamper circuit, when you study, the capacitor should charge fastly, right? Capacitor should charge fastly from the input voltage. Whenever it come out to be discharging should be slow, or discharging should be zero. So that's why at the discharging time constant should be very large enough that capacitor will not discharge during non-conducting cycles. Then only it will do the clamping circuit, clamping the waveform, right? In then, okay. Diode used in series to increase. If you are using the two diode in series, that will change which thing? Yes, reduce peak inverse voltage. Someone saying that. Anyone else? B, C, C, B, increase. See, whenever you connect two diode in series, this is the diode, and I connect another diode in series. If I apply a, let's take a reverse bias voltage of 10 volt here. So what happen if you are having a single diode there, then this 10 volt directly go to that single diode. So its peak inverse voltage is going to be 10. If you connect two diode there, they will divide half. Now it will take 5 volt in reverse bias. It will take the 5 volt in reverse bias. So what happen here? its peak inverse voltage is decreasing or increasing? Decrease. So peak inverse voltage is reduced. Got it? Yeah. What is this circuit? Yes, tell me what is this circuit? Yes, this is the circuit of voltage doubler. So answer what way? Voltage doubler. Yes. At the break point of a clipping circuit, diode will behave as a at a yes. At a breakpoint, the diode will behave as a short circuit and open circuit simultaneously. See, inside the circuits, there are and two or three diodes, right? If you are doing for clamper, they can behave as a short circuit as well as the open circuit, right? Which question you want to explain me again? Can you please explain question number 20? Okay, go back here. This is basically the basic circuit of clamper circuit, right? Oh, sorry, voltage doubler. For during the positive half cycle, let's take you are having like this. I'm having a square wave like this, right? This is Vm, this is minus Vm. So whenever you have a positive half cycle, negative half cycle, because this D1 diode will on in negative half cycle. So when you have negative half cycle, this diode will be on, and this diode will be conduct and negative half cycle. This will be negative plus Vm. It will be charged. Now it will be going off during the positive half cycle again. This will be on, right? And if this will be on short circuit, then here we are having plus minus Vm, right? And plus minus Vm, we are getting the 2 Vm here, like that. Next. Yes. Should I repeat that question again? If you didn't understand, I will repeat that 20 question again. Right. Of note. Do it. The rectifier which require minimum amount of filtering. Which rectifier required minimum amount of filtering? Okay, didn't understand. Don't worry, do it. I will explain that again. Which rectifier requires the minimum amount of filtering? That will be full wave rectifier. Okay. Right, B answer for this one, full wave rectifier. Let us do it again. The persons who didn't understand this question, I'm doing that again. Okay. If you studied the clamper circuit, let me remove everything again. Right. Everyone, let's try to understand here. See, basically what is happening, right? What is happening here? During the see, first thing we try to conduct this diode D1. In which cycle this D1 diode will conduct? Tell me that thing. This D1 diode will conduct in negative cycle. This D1 diode is conducting in which cycle? Negative cycle. During the negative cycle, what we are having, this negative cycle, this is negative, this is positive, Vm is here, and this diode will going to be short circuit. As this diode is going to be short circuit, what happened, this positive polarity will go here, this negative polarity will go here, and this diode, this not diode, this capacitor will be charged with this Vm voltage. Okay, after that, as this capacitor will charge with this Vm voltage, now next cycle is positive half cycle. In positive half cycle, what is happened to this input voltage? This input voltage is going to be plus minus Vm, and this diode is going to be off now, and this diode is going to be conduct now. Now what has happened, this capacitor will charge, this is Vm voltage, this is Vm voltage, they combine together, and here we get the 2 Vm voltage. So at the output, how much voltage you are getting now? That is twice of Vm. At the input, we are applying a Vm voltage, peak voltage, and the output you are getting the double of that one. And this is a constant 2 Vm. Now after that, it will not going to change. No diode will conduct after this, as it charged to Vm. So output is going to be twice Vm. That's why this circuit is called as voltage doubler. Understood or not now? Tell me. I think everyone understood this thing now. Next. First. Yes. Next. What type of diode circuit is used to add or restore a DC level to an electrical signal? That is what? Clipper or clamper? Yes, please. Clamper. Very good. The answer will be clamper here. Right. Next. The type of diode circuit used to clip off a portion of signal voltage above and below certain voltage. That is what? Yes, that is clipper. Very good. Yes, what is this? First, what is this? The circuit shown in the figure is positive clamper, negative clamper, positive clipper, negative clipper. See, basically, whenever you see the capacitor, the capacitor make this circuit as a clamper. Now, as you see, the diode is connected in opposite. It means what happened? During the negative half cycle, this diode will conduct output voltage is 0. During the negative half cycle, this diode is conduct and output will be 0. So which portion it will pass? Which portion it will pass? The positive portion it will pass. Negative portion it will clip. So which type of this one? This is a positive clamper, right? Next, silicon diode are less suitable for low voltage, low rectification operation because of its cut-in voltage is very high. You can't use for low voltage rectification because it's the cut-in voltage is very high, 0.7 volt. If it is 0.7, until 0.7 it is not going to conduct. If you apply input voltage below 0.7, that will not give you the correct rectifier output, right? That's why it is cannot be used. The half wave rectifier of an AC circuit supply voltage 60 Hz, then what is the AC ripple at the output? In half wave rectifier, the input and output both are same. So it means it will be B60. Yes, the ideal characteristic of a stabilizer. What are the ideal characteristics of a stabilizer? Tell me. The answer will be what? See, what is the stabilizer? Which will give you the constant output voltage. Very good. So constant output voltage, and if its internal resistance should be high or low? Low. So that there will be no drop inside that one. So total voltage will go across the or total stabilized voltage will go across the load. So answer will be A. The constant output voltage with low internal resistance. If there is internal resistance, due to that internal resistance, if the current through the stabilizer will change, the voltage of the stabilizer will going to be changed. That's why constant output voltage with low internal resistance. Next, Eber's small model is applicable to which? Eber's small model is only applicable to what? The bipolar junction transistor, the BJT. Yes, diodes are used to clip voltage in circuit because they act as a what? The diodes are used to clip voltage in circuits because they are act as a voltage source. They are act as a voltage source under certain bias conditions. So answer will be B here. The half wave rectifier made with a single diode and load resistance convert an AC voltage into a what? Yes, tell me the answer. Answer. The half wave rectifier made with single diode and a load resistor convert in AC waveform into what? Yes, please. Answer will be B. Someone saying sinusoidal voltage that has a DC offset. No, that's not going to be sinusoidal. If you draw the output waveform of a half wave rectifier, that will be look like this one, or it will be look like this one also. If diode is conducting for negative cycle only, it will be look like this one, right? So answer will be what? The waveform that has only the positive or negative half cycle of the input sinusoidal wave. Understood? So answer is here C, not constant DC. How you got the half wave rectifier as a constant DC? That is a having some ripples on that one, right? So answer will be C here. Next. See, the circuit which only shift the DC level without changing the shape, that is a clamper circuit. Good. Yes. The peak detector compares a capacitor and a ideal diode and AC source in series. Which of the following is true about that circuit? Read it and give the answer fast. It is a peak detector which detect the peak. See, basically, if you are having a peak detector here inside the circuit, this is, let's say this is the input. So it will be detect this peak, then again the next peak. So it means there should be no discharging here. So energy stored in the capacitor can never decrease with time. So answer will be D here. Energy remain constant, right? The answer will be D. The instantaneous current depend only on instantaneous source voltage. That is not the answer here. Answer is D for this question. The rectifier current is given to you. RMS value of the full wave rectifier is how much? RMS value. Tell the answer first. The RMS value is how much? That is RMS. Im by root 2. Im is right. So he is asking the RMS value. Oh, sorry, he is asking for average value, not RMS. I average here. So average value is going to be 50 root 2. Average or maximum, not average, maximum you can say. So that's going to be 70.7. 70.7. Check. Sorry. I think question is different. He is asking that RMS note. He is giving you. Yes, this is a very good question. I didn't see that. Read it again. This is a very good question. He says that RMS value of half wave rectifier is 50 ampere. So this is RMS value of a half wave rectifier. If you go from that one, the maximum value is, sorry, RMS value is going to be half wave rectifier Im by 2. So Im from here we get that 2 times 50, it means you are having 100 amp or milliamp amp. Basically, you are having a half wave rectifier first, then you replace that half wave rectifier with a full wave rectifier. If I replace that, Im value will not going to change of the source, right? Im remain 100. If Im is 100, now you have to calculate the RMS value of the full wave rectifier. That full wave rectifier RMS value is how much? 100 by root 2. That is going to be 70.7. That's the D answer, not 50 root 2. This is very good question. He related these two things, half wave as well as the full wave rectifier. Yeah, tell me the answer. Ripple factor of a ideal rectifier. If it is an ideal rectifier, it directly give you the DC voltage. It means its ripple factor is going to be 0 there. If one of the diode in a full wave bridge rectifier is open, the output will be, in bridge rectifier, if you open one diode, then the output will be, see, when you open up one diode, then that circuit will behave like a read the question again. If one of the diode in a full wave bridge rectifier is open, yes, very good, answer will be C. That will work like a half wave rectifier. Good. The answer will be C here. You can see this. If I open, uh, let us take, you open one diode, this is diode is here, but these two diodes can conduct for a complete cycle. Other cycle we are not getting anything. So it will be work like a half wave rectifier. Yes. The disadvantage of half wave rectifier circuit is what? Yes, please. Diode must have high peak inverse PIV rating. No, that's not the answer. See, whenever you are having a half wave rectifier like this, it is having the ripple, means they are having very gap inside the ripple. So it means it is very difficult to filter out the output voltage. The answer will be C here. Okay. The configuration of cascade amplifier. Which configuration generally known as cascade amplifier? Yes, please. Yes, very good. That configuration is CE-CB configuration, common emitter. Then we will, after the common emitter, we are having the common base configuration. Yes. No, no, not any configuration. In that one, you can only use the common emitter and common base. Right. Answer is C. The addition of emitter resistance to DC bias in BJT, stability of the circuit is improved. That emitter resistance is provide the negative feedback to your circuit, and that negative feedback will increase the stability of your some circuit, right? Yes. Next. In common emitter configuration, the transistor, the output voltage, sorry, the output voltage ampere characteristic is plotted as output common emitter configuration. So in common emitter, if you are going for output, The output will be taken across the collector terminal, right? Input is given to your base terminal, so that your emitter is going to be common. So generally, if you are going for the output characteristics will be plotted with respect to, sorry, VCE here and IC is here, and we are plotting like this. Remember, for the fixed value of IB is fixed, right? So answer will be C. He is talking about output characteristics, not input. Boomis. Got it? Yes. Amongst common base, common collector, common emitter configuration of amplifiers which have low voltage gain and high current gain. Low voltage gain and high current gain. Yes. So basically your common base configuration has high voltage gain and low current gain. Your current gain of your common base configuration is less than unity. If you go for common emitter configuration, its voltage gain is medium, but its current gain is very high. If you go for common collector configuration, its voltage gain is low and current gain is high. I'm again repeating, everyone try to listen this. Common base configuration has voltage gain high and current gain less than unity. If you go for what? Common emitter, the common emitter configuration has voltage gain as medium but current gain as high, and common collector configuration has voltage gain as low and current gain as high. So which configuration? The answer will be common collector configuration. So answer will be B here. Understood? So just make a table for that one, because most of the question he will ask in this type of exam from there. Just make that table which I taught you here. Yes, the voltage gain of a amplifier stage is lowest in voltage gain. Which configuration has the voltage lowest voltage gain? The same, the common collector configuration. Answer is C. Very good. Ideal value of input resistance of a trans resistance amplifier. Trans resistance amplifier. Yes, it is a trans resistance. Infinity, infinity, infinity. Yes, please. Answer is B. Whenever you go for trans resistance amplifier, its input impedance is 0 and its output impedance is infinity. right? Yes. Tell me the answer for this question. The amplifier has a voltage gain of 100 and input voltage is 65. The output voltage is going to be 65 into 100. That is going on 6500. This is in millivolt. If you convert that into volt, 6.15. There is no answer is matching. Oh, sorry, it's not 1.5, 6.5. Sorry. 6.5. That is answer is A. Yes. Which parameter of a amplifier is calculated when your Vs is 0? Vs means source voltage is 0. If you remember, in case of amplifier, if you want to find the output impedance of that circuit, then you have to do the source voltage as 0, right? It means the answer will be output impedance. Yes. The common emitter configuration beta is given to you as 100. The base current is given to you as 30 microampere collector current. The relation between base current and collector current is beta times IB. Just multiply this one with 100, you are getting 3 milliamp. Answer is B. The current amplification factor of a common base connection is 0.5. What is the base current if emitter current? What is the relation between current amplification factor means what? Alpha is given to you 0.5 and emitter current is given to you, that is 1 milliampere. So we have to calculate the value of base current. How much is the base current? That will be 0 milliamp. How? Okay, A 0.5. He is talking about the base current, Madhu. See, basically alpha, if you remember, alpha is how much? IC upon IE. So from here I can calculate the IC value, that be how much? 1 into 0.5, that is going to be 0.5 milliamp. That is your IC. And if you want to calculate your IB is going to be how much? IE minus IC. I is 1 minus 0.5, that is going to be 0.5 milliamp. A common emitter amplifier, the unbypassed emitter resistors provide you fourth. Which type of feedback it is providing you? The emitter unbypassed resistance. I already discussed this thing in previous questions. that your emitter resistance is always provide the negative feedback to your circuit. It will be negative voltage feedback. Yes, good. Two more question from analog electronics, that emitter follower configuration is an example of for which type of configuration? Emitter follower. Emitter follower. Emitter follower is an example of voltage series feedback. Remember that. That is an example of voltage series feedback. Yes. The transistor amplifier circuit has VCE is equals to VCB plus what? Yes, A. That is VBE. Good. So answer will be A for this one. Now next 50 questions from EMFT. Yes. Let's start with this one. Which one of the following is not correct? Which one of the following is not correct? B. B is not correct. Okay. See, B is not correct here because it is missing one term, that this term is should be del D over del T, or you can say epsilon times del E over del T. Then only it is true, right? The B is correct answer. It is not correct here. So you can see I already gave you the all four Maxwell equations because it is Maxwell equations. That is the Faraday's law. This is Ampere's law. There is epsilon is missing, right? Ampere circuit law. This will give you the Gauss law, and this is told you that no isolated magnetic charge is available there, right? Okay. Next, the third Maxwell equation is given by what? The third Maxwell equation is given by good, correct. Answer is A. See, this is the order of Maxwell equation. You can check the first Maxwell equation, del dot B is equals to rho V. That is your first Maxwell equation. Del dot B is equals to 0. This is your second Maxwell equation. Third is del cross E is equals to minus del B over del T. And the fourth Maxwell equation is del cross H is equals to J plus del D over del T. So this is the order of Maxwell equation. Sometimes he asks you that which one is the second, third, or fourth Maxwell equation. The answer will be A here if he is going for the third Maxwell equation. See, B is not correct. Someone are giving the answer B because inside the B the minus sign is not there. B is not correct answer. Oh, it's misplaced. For static and magnetic field in an homogeneous source free medium, which of the following represent the correct form of two Maxwell equation? See, basically they are two combined. They are two combined Maxwell equation. These are two combined Maxwell equation, and these are two combined Maxwell equation. You have to tell me which pair represents the correct. Which pair represents the correct order for static, electric, and magnetic field? See, if you go here, these are the Maxwell equation which you are seeing here. If your field is static field, static means that is not a function of time. If you take the derivative, because electric and magnetic both field are not function of time. If you take the derivative with respect to time, we take the derivative with respect to time, that is going to be zero. So this equation remains same, this equation remains same, this equation is modified and it is become zero on the right hand side, and this del cross H is going to be J on the right hand side. So which option is correct? For a static and magnetic field, del dot E is not zero, and second del dot is not zero, del cross E is zero, but del cross B is not zero, that is Jc upon mu, and del cross E is zero, del dot B is zero. This is the correct answer here, right? It is representing the static, electric and magnetic field Maxwell equations, right? Next, the charge-free space, the Poisson equation result in which of the following? The Poisson equation results in which of the following? That represents the Laplace equation. That is the result of Laplace equation, right? Correct. Yes. The magnetic flux phi linked with a coil in at an instant t is given by this one. Then he is asking about the induced EMF in the coil at instant t equals to 0. So you can directly apply the Faraday's law. The EMF is how much? D phi by dt. Right, and you can take the derivative here. That is going to be 4t minus 20. Minus is also there outside. So minus 4t minus 20, and you will replace the value of t. He is asking at t equals to 2. 8 minus 2, that is going to be minus 4 into 2 minus 20, that is going to be 12. So answer will be 12 volt here. Yes. A infinite plane at y is equals to 6 meter, there exists a uniform charge density of 1 by 600 pi microcoulomb per meter square, the associated electric field strength. So whenever you are having a infinite charge, surface charge density like this, if you are calculating the electric field from that one, the electric field is uniform, that is rho s by 2 epsilon, that is the value of that electric field, and it is always directed normal to that plane towards that point. So what is happening here? This is at y equals to 6, and there exists a uniform surface charge density is given to you. He is asking for the electric field, right? The electric field is always going either in plus j direction or in minus j direction. So there are only 2 plus j. So it means electric field is asking for the j direction. Now he is asking for the magnitude. Rho s is given to you 1 by 6000 pi into 2. Epsilon value is how much? Epsilon value is how much? 1 by 36 pi 10 raised to power 9. So 36 pi divided by 10 raised to power minus 9. And that will be in micro, means 10 raised to power minus 6 there. So you can solve it. So it's going to be pi to pi cancel out, and 1000 combined with 10 raised to power 9, 10 raised to power minus 6 is cancel out. We are getting how much? 6, 36 by 6 is 6. So this is going to be 3j volt per meter. Which, with the symbol having their usual meaning, which of the following is correct? Not correct relation. Which of the following symbol having their usual meaning, which one of the following Relationship is not correct. Check and tell me. Okay, Sandeep saying that in question 3, let's go to the question 3. One second, Sandeep. Yes, what he says? Question 3, option B is also correct. How the option B is correct? Del dot D is how much? Okay, source free medium. He's talking about source free. Yeah, source free medium it will be, but he's not saying that. Oh, sorry. He says that source free medium is also. Yeah, that is also correct. If he's saying source free medium, right? If it is not source free, then only D1 is correct. Let's go to this one. Yes, what will be the answer for this question? Seventh question. Yes, Sandeep, you are correct. The symbols usual meaning which of the following correct, not correct. See, in this relation, what is the missing? Can anyone tell? In the A part. Yes, Sandeep, you are correct. Yes, what is the missing in this equation? See, basically, if you go for this one, this is the integral form of Maxwell equation, and in that one, there should be a mu term here also, right? Because that will be derivative of B dot ds, not H. So H is not there, it will be B. If you want to H here, there should be mu with that one also. So in this one, the things is missing here, that is mu. So this equation is not correct. This is incorrect. So correct answer is A, not B. Inside B, what you are seeing is missing. Nothing is missing. Right? Answer is A. Yeah, if he write I here, I means what? That is the line surface integration of J. Right? This equation is correct. Don't be mess with that thing. There should be not J. There should be I here. This is the correct equation. But the answer is that one. In this equation, the first equation, the mu is missing. Understood? Yes. Tell me the next. The relationship between electric field and current density. J is equals to sigma E. Answer is D. In EDC, we already studied these things. This is called Ohm's law. The another form of Ohm's law. Electromagnetic wave are produced by what? The electromagnetic wave are generally produced by accelerating charge or moving charge. Tell me the answer between these two. Accelerating charge. Very good. That answer is accelerating charge. Why not moving charge? Moving charge will produce a constant current, and constant current will produce not a time varying electric field or magnetic field, right? That will produce a uniform or constant static magnetic field. A static magnetic field cannot generate an EM wave. So we required a time varying field that can only be generated by a accelerating charge. A electromagnetic wave is going through a vacuum is described by E is equals to E naught sine of kx minus omega t and B is equals to B naught sine of kx minus omega t. Then what is the relationship between E naught and B naught? So always remember that E naught upon B naught is always equals to C, and C can be written as omega by K. So E naught is multiplied with K and omega is multiplied by B naught. So answer will be A here, right? Which of the following note a Maxwell equation for static electromagnetic field in isotropic and homogeneous medium? Isotropic and homogeneous medium. These all are correct. This is incorrect because there should be a minus sign here. Del square A is equals to minus mu into Z. Maxwell equation for electromagnetic is not applicable. The Maxwell equation are already applicable for isotropic medium, non-homogeneous medium, non-linear medium. They are not applicable for a medium which is moving with respect to the coordinate system. If your medium is moving, then that will not be applicable there. The Maxwell equation are not applicable there, right? Static electric field is irrotational, which can express as, if your field is irrotational, what is the meaning of that one? The curl of that field is zero. Irrotational field means the curl of that field is zero. Electromagnetic field is radiated from a stationary point charge, a capacitor with DC voltage, a conductor carrying a DC current, and oscillating dipole. So basically he is talking about electromagnetic field means EM wave. The EM wave can be generated only through the oscillating dipole. The type of variation delta upon delta t implies with reference to the field quantity in Maxwell equation, that is for both sinusoidal and non-sinusoidal. The answer is C here. That is for both sinusoidal and non-sinusoidal. The electric susceptibility and relative permittivity are related as. Yes, answer will be A. Very good. Xi A is equals to epsilon R minus 1. That is the relationship between susceptibility and relative permittivity. The relation between three vector E, P and D is E, P and D is. The relationship is epsilon naught E plus P. D is equals to epsilon naught E plus P. The twin wire transmission line in air, the adjacent voltage maxima are 12.5 and 27.5 apart. The operating frequency, see, whenever you are having a transmission line or EM wave, the The maxima are, adjacent maxima are how much distance apart from each other? That are apart from lambda by 2. Two maxima are apart from lambda by 2. One maxima and minima are apart by lambda by 4. So if I go for lambda by 2 is given to you how much? The distance between these two is 27.5 minus 12.5 will give you 15 centimeter. That is lambda going to be 30 centimeter or 0.3 meter. If you calculate the frequency is c by lambda. C is 3 into 10 raised to power 8 divided by lambda, we calculated 0.3. So it's cancel out, it's going to be 1 gigahertz. So answer will be B here. The characteristic impedance neta. Yes, neta is how much? Under root of mu naught upon epsilon naught. So answer will be B for this one. Under root of mu naught upon epsilon naught. Very good. Yes. The electric field component of a time harmonic EM wave traveling in non-homogeneous, non-magnetic lossless dielectric medium has an amplitude of 1 volt. If relative permittivity of the medium is 4, the magnitude of time varying power density vector is what? So first we have to calculate the neta of that medium, that will be 120 pi divided by under root of 4 is going to be 60 pi. So if you remember, he is asking about time average power density, that is Poynting vector. So P average is going to be 1 by 2 E naught square divided by neta. So how much we are getting? E naught is 1 divided by 60 pi into 2, 120 pi. So answer will be C, 1 upon 120 pi. The wavelength of a wave having propagation constant, this one is equals to the wavelength of a wave having propagation constant. Gamma is given to you. Always remember, gamma is alpha plus j beta or k, and beta is 2 pi by lambda. So beta is given to you 0.628 and it will be 2 pi by lambda is equals to 0.628, right? And 2 pi value is how much? 6.28. 6.28 is beta 2 pi value and 0.628. So lambda is going to be 10 meter. Directly 10 meter. So he will not give you difficult calculations. Remember, if he will bring some numerical, the calculation is very easy. If you know the concept, it will not taking more than 1 minute. It just take 30 seconds. The return loss of a device is given to you. The voltage standing wave ratio and magnitude of reflection coefficient is what? Do it. So if you go for return loss is how much? Minus 20 log of 10 base mode of reflection coefficient. Return loss is 20, 20 is cancel out, 10 raised to power 1. That is going to be mode of reflection coefficient is going to be 0.1. Check it. Mode of reflection coefficient is 0.1. Now we have to calculate the SWR. So SWR, VSWR is 1 plus mode of reflection coefficient divided by 1 minus mode of reflection coefficient. That will going to be 1.1 divided by 0.9. So it's going to be 1.22, something like that. A. will be the answer for this question, right? The numerical value of ratio of electric field intensity to the magnetic field intensity. Remember, E by H is always equals to neta, and neta value is 377 or 120 pi. So answer will be B, 377 ohm. The condition for transmission line to be lossless. So in lossless transmission line, the resistance should be very low and conductance should be very low, negligible. So what should be the answer? Yes, please. The answer will be C. Very good. R should be very less than omega L, and G should be less than omega C. Impedance inversion may be obtained with what? Impedance inversion is obtained what? So impedance inversion can be obtained with the help of quarter wave transmission line, because it will used for matching purpose. For with the help of this one we can also achieve the impedance inversion, right? The phase shift constant of a distortionless transmission line is equals to distortionless transmission line. What is the phase constant? Yes, please. The phase constant for distortionless line, the beta is equals to omega under root of LC. Very good. B is the answer. Correct. The attenuation and phase constant of a distortionless transmission line will be what? Attenuation constant. Attenuation constant is not zero for a distortionless line. This is distortionless line, not lossless line. Right, Ansumar? So if you calculate the attenuation constant of a distortionless line, that will be under root of Rg, and if you calculate the phase constant of that one, omega under root of Lc. But there is a condition here that there is a condition here that L by R is equals to G by C. So when you replace that condition, you can change that one and this term into this one. So you will got this answer B, right? Yeah, that is the complete process. R by L is equals to G by C. The characteristic impedance of a quarter wave transformer with load and impedance is given by. See, always remember that thing. If he is asking about characteristic impedance of line, that will be under root of ZL and Zi. So it's going to be 30 into 75. 30 under root of 30 into 75. So how much is this? 47.43. See, load impedance is given to you. Characteristic impedance is given to you. He is asking about the reflection coefficient. ZL minus Z naught divided by ZL plus Z naught. ZL is 100 minus 50 divided by 100 plus 50. So it's going to be 50 by 150, that is going to be 1 by 3. So answer will be D. The Pointing vector P E cross has a unit. The Pointing vector generally represents the power per unit area. Power per unit area. That means watt per meter square. Okay, the frequency is given to you, sigma is given to you, mu is given to you. He's asking about the skin depth. So skin depth formula is 1 upon under root of pi f mu into sigma. This is not mu, it is mu r, remember. Mu r is given to you. So you directly put that value, you will get the skin depth value. Answer is A. Find the SWR if the reflection coefficient is 0.8. SWR and reflection coefficient has a relation 1 minus mode of reflection coefficient upon 1 plus mode of 1 plus and divide minus. 1 plus mode of reflection coefficient divided by 1 minus mode of reflection coefficient, 1.8 divided by 0.2, that is going to be 9. Right? 1.8 divided by 0.2 is giving you 9. Right, wave velocity, wave group velocity is given to you. Is asking about phase velocity. So the group velocity and phase velocity has a relation. Phase velocity into group velocity is always equals to c square. So if you go for group velocity, phase velocity, so the phase velocity is going to be 9 into 10 raised to power 18 is c square divided by how much? 2 into 10 raised to power 8. So the phase velocity is how much? You can check it out from there. No answer is correct for that one. That is 4.8 into 10 raised to power 8. Sorry, not 18. This is 16. That is the correct answer. Okay. ZL is given to you, ZI is given to you, quarter wave characteristic impedance, that is the same type of question. Under root of ZL, ZI, 50 into 200, when you do that one, this will give you the 100. The depth of penetration of a wave in lossy medium increase with increasing. See, what is the formula for depth of penetration? Delta is equals to 1 upon under root of pi mu sigma f. Pi f mu sigma, right? That is the formula for skin depth. So now what happen? If you increase the, what should you increase to increasing this skin depth? Yes, please. C. Wavelength. If you increase the wavelength, then your frequency will decrease, and then frequency decreasing, it means skin depth will increase. Okay. See, basically in this question, what is happening here? He is asking, see, every time read the question carefully. This is the skin depth for which medium? Which medium is this one? This is for conducting medium. Good conducting medium. And here, what is so talking about? Lossy dielectric medium. Here he is talking about lossy dielectric medium. In lossy dielectric medium, the alpha value is how much? In lossy medium, alpha value is sigma by 2 under root of mu by epsilon. And as you know, the skin depth is inverse of alpha, so 2 by sigma under root of epsilon by mu. So in lossy medium, that will not depend on the frequency. Understood, everyone? So read the question carefully. In BL exam and like this exam, we generally don't read the question carefully. We know the formula and we will go with that one. So read that question carefully and we will go with this one. So what is happening? If I increase this epsilon, then your skin depth is going to increase. So answer will be D. Got it, everyone, or not? So every time read the question carefully, then only give the answer. Otherwise, you will make the mistake. Yes. For a lossless line terminated at short circuit, standing voltage minima and maxima are separated. Whenever he is talking about the distance between maxima and minima, that will be lambda by 4. If he is talking about distance between maxima lambda by 2, so answer will be D here. Good. Yes. Lambda by 4, a lambda by 4 line sorted at one end present in present impedance at the other end equals to. So basically he is talking about the short circuited lambda by 4 line input impedance. He is talking about short circuited lambda by 4 line input impedance. So if you go for the input impedance of a lambda by 4 line, that will be Z naught square divided by ZL. Right, for lambda by 4, so line input impedance is Z naught square divided by ZL. If your ZL is infinity, that is going to be, sorry, yeah, ZL is infinity, it is going to be 0. If ZL, because he is giving you short circuited line, if your ZL is 0, then it will be infinity. So here the line is short circuited, it means ZL is 0, so your output will be, input impedance will be infinity. Got it? Yes. Whatever the minimum value of VSWR may exist on a transmission line. So VSWR has its minimum value, that is 1, always greater than 1. It is going from 1 to infinity, right? Which of the following express the phase velocity in microstrip line? Microstrip line has a different property than the normal. Answer will be B. Yeah. Answer will be B. C upon epsilon effective. This is effective permittivity there, right? Because in whenever we are talking about my microstrip line, the permittivity inside that microstrip line is different from the normal permittivity. That's why this formula is seeing C upon under root of epsilon E. Answer is B. The quarter wave transformer can be used for matching accurately. Yes, which type of load it will be? Yes. The quarter wave transformer is mostly used for resistive load. Non-resistive load, it will not work. For non-resistive load, we generally use the parallel transmission line for matching purpose, right? Parallel open circuited, or you can say shunt for open circuit or short circuited line. Okay, the answer for this question. The VSWR measured a square law detector is used to detect the signal level, right? The voltmeter read maximum and minimum value is this one, then VSWR. VSWR is always Vmax upon V minimum. Remember that. This is Vmax upon V min. 64 by 16. That is going to be 4. Yes. The electromagnetic wave is transmitted into a conducting medium of conductivity sigma, the depth of penetration. What was the formula for that one? 1 upon under root of pi f mu sigma. Directly proportional to frequency is not correct. Directly proportional to square root of frequency is also not correct. Inversely proportional to the frequency is not correct. Inversely proportional to the square root of frequency is correct. Yes, Ex and Ey is given to you. Wave is traveling in z direction, right? What he is asking here? He is asking about the average power, P average. That is missing line there, right? P average you have to calculate. Average power density. So first we have to calculate the magnitude of electric field. That is going to be how much? Under root of 3 square plus 6 square. Right? How much is this? This is under root of 45. Now we have to calculate the P average. That is under root of, sorry, not under root, E naught square divided by twice of neta. So E naught is 45 divided by 2 into 377. Solve it, you will got the 62.5 meter. See, basically it is having both x component as well as y component, right? And the x and y component has the same amplitude. It means it is a circular polarized wave. And if it is a circular polarized wave, then which type of polarization is this? Left circular or right circular? Tell me. That is a left circular polarized wave is there, right? Because it is having E naught and minus j sine of beta z. That wave gives you the left circular polarization of the wave. The Maxwell equation are obeyed by the EM wave while it is propagating. So in which medium the Maxwell equation will be followed by EM wave? Sorry. Yes, please. In which medium? Only in free space. No, that's not correct. No. See, Maxwell equation can be followed in any medium. Either it is solid, liquid, gas, or any medium. Right? The answer will be D. In all solid, liquid, gas, and all the medium mentioned above. All the medium. Which one of the following statement is correct? A right circular polarized wave incident on a air into a polystyrene which is having epsilon naught, the reflected wave. Always remember, whenever you are having a right circular polarized, the reflected wave will be left circular polarized, opposite to that one. Right? That is left circular polarized wave. PDF I will be sharing in the group. Don't worry about that thing. What is the major factor for determining whether a medium is free space, lossless dielectric, lossy dielectric, or good conductance? So basically, we are deciding the medium on the basis of sigma upon epsilon, sigma upon omega epsilon, right? That will be depend on this thing. So basically, the major factor which is defining that which type of medium, loss tangent. Good. This is defined sigma upon omega epsilon, generally known as loss tangent. So on the basis of this one, we will define the medium is which type of that one. Uniform plane wave, again E upon H is going to be neta. Neta is under root of mu by epsilon. The Poynting vector piece has a dimension, that is power per unit area, volt, power volt per unit length, that is power per unit area. And the last question, the resultant of reflection from a plane wave conducting plane, the electromagnetic wave acquires an apparent velocity greater than the velocity of light in space is called as what? See, basically, whenever your wave is traveling through a bounded medium, let's take waveguide. Wave is traveling, and wave will, when wave is, you can say, strike on this boundary, it will be reflected by that conductor. It will go here like that. So it will be propagating with a higher velocity. That is called as phase velocity. So generally, the phase velocity will be greater than for the EM wave in the bounded medium. So that velocity is, note this, the phase velocity, right? So answer will be D. So hopefully you are enjoying this session, right? This is very good questions, and some questions are really good, which I already taught you that you have to be more focused, because generally this type of exam, what is happen with the students, that they will go with the flow. They didn't read the question carefully and they mark the mistakes. And in these type of exams, the major thing is that you generally do one or two mistakes and you go out from the exam, you are going out from the competition. Let us take you are currently at 82 and you make two mistakes, right? Two or three mistakes there, then you will be come out to be 80, right? So that will make a big difference for you. If cutoff is 81, then you will come out from the, you can say, the competition. So be careful. That's why I put two or three questions, right, in between complete, you can say, the session. Two or three questions are there which are where you have to be more focused, right? So go with the full confidence. You can do that one. This is not a very big exam, you can say very difficult exam. It's easy exam. You can crack that, and you can get selected there, right, if you prepare well. And be, I'm again saying, be careful with that one, because generally the mistake chance is there in the easy questions, where you left something and where you forgot to take something, that will make a mistake. Okay, hopefully you enjoy this session. Thank you.